You learn about the capabilities of Microsoft compliance solutions. In Module 1, we will describe the concepts of security, compliance, and look at identity concepts. So let's get started with Module 1. In Module 1, we'll look at the concepts of security, compliance, and identity. This module is broken down into 2 lessons. We'll look at the security and compliance concepts, and then we'll move on to talking about identity concepts. Let's have a look at the first lesson in this module. We will start talking about difference in depth as a security model. We'll move on to talking about another module called Zero Trust, and then we'll move into looking at the concepts of encryption and hashing, and finally talk about some basic compliance concepts. Let's start with shared responsibility model. This identifies the security tasks that are handled by the cloud provider or by the customer. Typically, when you're working with on-premises environments, you'll have all your hardware, your operating system, your applications, all managed by you and set up by you. So you manage the entire environment. That's why you'll typically see on this screen, everything that is listed for on-premises is managed by the customer. When you move your services into the cloud, things slightly change. Depending on the kind of solution you're picking up from the cloud environment, it might vary. For instance, if you look at infrastructure as a service, or in short IaaS, typically in an IaaS environment, you will have your cloud service provider managing everything that's in the back end on your environment in terms of your physical hardware, because you're putting your services on a Microsoft data center, and that data center is maintained and managed by Microsoft or your cloud service provider. So you don't have to worry about managing all the hardware aspects of things. Now, things that you would have to manage on top of that would be anything that you install and implement. Typical example of an IaaS environment will be a virtual machine. Now, within a virtual machine, you would not have to worry about all the hardware aspects of it, but your responsibility will start from you choosing an operating system that you want to install, and then managing and security patching and updating that operating system and any other application that you install on top of that. If you look at some other examples, we talk about PaaS, which is platform as a service. Within PaaS, you will have slight variation of things, depending on the kind of solutions you're picking up. Now, within Azure, we offer a lot of different PaaS services that are offered to you to implement. However, clients and customers do decide to choose or bring their own custom-built CRM or ERM systems that they want to use within our PaaS environments. Now, depending on the solution that you are implementing, you might have to manage them differently. In this case, if you look at the diagram here, you can see everything including that was part of IaaS or infrastructure as a service, and the operating system is now managed by your cloud service provider, in this case Microsoft. And there are a few things that are shared between the client and Microsoft. Now, this particular part depends on if you are bringing your own solution onto your platform. That means you will be then responsible for managing that part. So if you're bringing your own CRM system, you'll have to manage the application that you're bringing, keep that up to date, and patch it and update it as and when needed. And if you are picking one of our solutions that's offered to you under PaaS, then we will manage and maintain that service for you, and you simply carry on looking at implementing that and bringing your own data to that application. Finally, we'll look at the third option, which is called SaaS, software as a service. Now, within software as a service, we provide you an environment where you can simply log in and start utilizing an application or a software solution. In this case, if you look at all the responsibility that lies with your cloud service provider, in this case Microsoft, you'll see that all the way up to application is responsibility of Microsoft. So they manage everything for that particular solution that you're picking up as a SaaS or software as a service. However, there is one area that is still shared responsibility, and that's identity and directory services. Now, in Azure, we talk about this as Azure Active Directory as one of our identity and directory service. It depends on the organization to ensure that they need to make sure that is secure and set up correctly, including all the users and groups that they're creating within Azure Active Directory, and they're up to date. As our responsibility in Microsoft, we need to ensure that this service is up and running and does what it says as part of a service. So there's a shared responsibility to ensure we still provide identity and directory infrastructure in your solution. Everything else is responsibility of your customers or clients. And again, typically you'll see data and information is client's responsibility in all these models. Let's look at defense in depth. Defense in depth is a layered approach to implementing security. We want to ensure that we are not just securing our environment from one point, but we want to implement the security across different areas. I'll give you a simple analogy. Imagine you have an office environment, and just putting up a security guard outside the building is not good enough. What if somebody sneaks by that security guard and they can then walk around anywhere in the office, any building, any part of the floor in the building, and they can wander wherever they like, which is not something that we like to do. So we would like to implement security in all places. Typically a tongue-style gate, maybe they need to use their smart card or some sort of ID to go through them. Again, within the lifts, they can't jump onto any floor. They'll have to use their identity again. And once they're on the floor, they might not be able to go through all the doors and every room. They might be locked. We want to do something similar in our solutions that we implement. We want to make sure that at every different stage, we can challenge users or people that are trying to access your services and reach to your data. For that reason, we use this layered approach. Now, within this layered approach, we'll look at different areas that we can implement security. When we start talking about physical aspects, we'll look at all of the data centers that we have and how people can come or try to get closer to our data centers. Now, if I was to go to one of our data centers and just turn up without booking myself in for any particular reason, I wouldn't be allowed in. I'll be turned away. And this is where our security on these data centers is very strict. So you have to make sure you have an appointment, and this appointment has to be for a particular task that you're there to do, not just to wander around. And even if you do have a task to complete, they won't just let you go around anywhere in the environment, and they're quite tight guidelines on what you can and can't do when you reach to a data center. So this security involves quite a few other things. Checks on the perimeter, security cameras, and many other things to avoid anyone trying to sneak into one of our data centers. So that's the physical aspect of the security. Now, once you go past the physical security, we talk about identity and access. Now, physical identity checks would be looking at your identity cards or any other sort of identity that you might provide. In the cloud environment, when you start looking at your solutions, we look at this as you providing and authenticating yourself on who you are before you're allowed to log into your services. Typically, you'll use services like Azure Active Directory in this case to authenticate and provide access to users. Now, when we go down into looking at other solutions like or other layers like perimeter layer, this is where we want to implement security to all the solutions, so the data that is coming into your network can be filtered and assessed before it actually reaches your network environment. Kind of things that you will normally implement, surely we've all heard of firewall, and we look at other defense mechanisms like distributed denial of service attack protection. Now, we'll talk about some of these at a later stage within this course, but these are the kind of security that you want to implement for any packets that are moving towards your network, and prevent them from even reaching your network environment if they're not allowed to, or if they shouldn't be traveling towards your solutions. Once into your network environments, we want to ensure that your network is secure in many different ways. One of the ways would be that you don't want to leave your network environment as one large network area. We'd like to segment this network, and this is what we call subnetting. And we subnet or subgroup your network environment just to ensure that we are not letting any packets of data loose within your entire network, and it's controlled onto which network or subnet this data should travel into. In this case, if there was any corruption at any stage or a malicious attack in any part of your network, it doesn't corrupt your entire network, but can be limited to a subpart of your network or a subnet. Now, within this, we'll talk about some security elements like NSG or network security groups that we can implement at this stage to protect or control the flow of traffic between these subnets. Then you can move down onto the compute level. This is where we look at your resources that you can implement in terms of resources in Azure like virtual machines and any other compute resources that you can think of. Typically, we'd like to ensure that these services are controlled and the access to these services is only limited to people that are allowed to log in. So control permissions on who is logging into these services and what they can do with these resources once they are logged into them. Then we want to move into looking at application layer, talking all about applications and what type of applications we've got running. Are they up to date? Are they secured? And the kind of capabilities these applications have. And finally, talking about data that we have within our environment or in our cloud. Typically, we want to make sure that this data is encrypted no matter where it is. In Azure, your data is encrypted at rest or at move if you're moving between different services and between your end clients. So data encryption to ensure that people can't get access to data if they have managed to breach through all these security layers that you've implemented. Let's move on to talking about a different cybersecurity strategy. Now we're looking at CIA. Now, bear in mind, we're not talking about the Security Intelligence Agency in the US. We're talking about confidentiality, integrity, and availability. Now, these three topics kind of form the foundation of security in all aspects. We want to make sure that the data that we're working on or the projects that we're looking at are kept confidential for those who are allowed to look at them. For instance, if you're working with this data, you don't want anyone else to see this information, regardless of anything that is inside this data is sensitive or not, because you should be able to keep this data away from those who shouldn't be looking at this information at all. So we want to make sure our information or data is kept confidential. In a work environment, you would want to allow permission to those who can look at this information rather than leaving it open for anyone on the network to explore this data or maybe exploit it if they wanted to. So for that reason, we want to ensure that data that we have can be kept confidential. Now, there are different ways of doing it. You can apply permissions on who can see this data. We can apply encryption to ensure that data can't be taken by people and open and explored. And you can add other ways like password protection to some of these files so they cannot be opened by everyone. Then we want to move on to talking about integrity. Now, integrity is making sure that we can rely on that data or that message that we've received, making sure it is in its correct form and it's not been amended or altered by someone either in transit or wherever it's stored. For instance, if I receive a project file, a budget file, or someone's expenses for that reason, I want to make sure that's the original data that I was sent and it's not been amended by anybody on the transit or where it's stored, just to make sure the figures or the information that's there is correct. So we want to ensure a method where we can find out the data that we are using is reliable and we can utilize it without worrying about any amendments or changes made to that information. Finally, we want to talk about availability. This refers to data being made available to those who should be working with it. For instance, if I have access to a project or file that I'm working on, I should be able to open that and work with it as and when it's appropriate for me to work with it. A lot of the time, you'll see different malicious attacks happening in where you no longer have access to your file or projects. And this is where we want to ensure that we can eliminate that particular issue by making sure the services that are supposed to be available for you are made available for you when you want to access them. So looking at the availability as part of that triad in CIA. Now let's start talking about Zero Trust model. Our world of technology is changing and evolving very fast. And because of these changes, attackers have the ability to sometimes bypass our conventional access and management solutions. We want to come up with a concept that can allow or secure our services in a way that they can be protected regardless of the new implementations and changes that have been brought into the environments. For this reason, we'll look at a model that is called Zero Trust model, which simply implies or goes by one principle, which is trust no one and verify everything. This simply means that assume everything is kept on unprotected and open network environments. And you need to ensure that you can verify and test everything that's happening within your environment. We can do this by looking at the Zero Trust guiding principles. Starting with verify explicitly. We want to ensure that everything that's been used in the network environment or in your services can be verified and challenged at different stages to ensure that it is an approved or correct service that's running in your environment. Then we want to make sure we apply or provide least privilege access to users and services that are working in your environment. For instance, if you want to apply or raise someone's abilities to do or carry out a task, we don't want to give them administrative access to complete or work with everything in that environment. We want to make sure we give them enough access so they can log in and do the task that they're required to do. For that reason, we talk about things like just enough access, or looking at just in time access. So in short, just in time or just enough access, which means we want to make sure that if, for example, I'm about to create something, I might request my rights to be elevated for a time period so I can go and carry out that task, and after that time expires, I'm no longer allowed to do that task. So just in time access, or just enough access to be able to create that particular task that I'm about to do and nothing more, not the ability to control everything within my network environment. So not a full administrative right given to me just for that particular task is what I'm looking for. So least privilege access. We also want to assume breach at all times. So have a mindset that your services can be breached at any time. For that very reason, always analyze data and network traffic that you have within your environment, just to ensure that you are in control of everything that's happening, and if you need, you can implement any security solutions. Now, this approach should be extended to your entire digital state, and it's not just used as a philosophy, but also implemented as an end-to-end solution. And you can do this by using the 6 foundational pillars that we have in Zero Trust model. We look at identities, and we want to talk about users, devices, services, applications, all these identities that can be authenticated and challenged with stronger authentication. We talk about devices, and this can be any device or any hardware that's within your network environment, to make sure that we can assess them, because they can create a large attack surface area. We want to make sure to have your environment or your setup has full visibility of all the hardware that's available within your network environment or within your solution. With applications, you want to make sure that you have the visibility of what application your organization uses, and also ensure that there are no shadow IT applications. Now, shadow IT applications are referred to applications that are not permissible or unsanctioned applications that can be installed by users in a network environment. Typically, your organization will use applications to manage a lot of different type of data in your organization. For that very reason, you want to make sure that these applications are controlled, and you can identify if there were any unsanctioned applications being installed or utilized within your environment. Then we want to talk about data. Now, typically your data should be labeled, classified, and encrypted wherever it is kept or when it is in transit. We talk about infrastructure. This could be your cloud services, your on-premises environment, or something that you have that is implemented in a hybrid environment, and that should be all monitored as well. Finally, when we talk about network, we need to make sure your network is segmented and you're able to control the different segments or different subnets within your network environment in real time and monitor this data. One way to mitigate cybersecurity threats is to look at encryption. Encryption typically allows you to take your data that's in readable format and convert it into non-readable format for those who should not have access to it. So if they were to grab this data either where it's stored or on transit, they should not be able to look at this data and understand anything out of it. So it's kind of jumbled information for them. Now, for those who should have access, they should be able to use some sort of method to convert this information or unreadable data back into readable format. This is the process of encryption and decryption of data. Typically, we have two different formats that we use within encryption. And depending on the need, we will use different types of encryption methods. Now, let's have a look at symmetric encryption type and understand how that's different and when it can be used. For example, if you look at the screen on, where we can see symmetric encryption, you can see I can have something that is plain text, and I want to ensure that this plain text is converted into encrypted file or encrypted data, and it becomes non-readable. Now, to do this, typically you'll need to use a key. This key is typically an algorithm that you're using in the backend to convert this simple plain text into non-readable format. Once this data is converted or encrypted, anyone that gets access to this data without that particular key should not be able to read or get to the information that's within this file. Now, for me to log back into this file and understand what's written in it, to see the content behind it, I'll simply need to use a key that I originally used to encrypt this information to then be able to get back to the data or the file that I need. Now, you get to see a lot of these encryptions or symmetric encryption happening with services that typically are used by applications like your messaging apps, your banking apps, and maybe storage accounts as well, where they can simply allow you to log in, and when you authenticate, they decrypt your files or access to your services, and you can work with the content that's within it. And if you log out, then that access is blocked or that service is encrypted. Anyone else that's trying to look into that file or that particular resource, they should not be able to read any information out of this. Now, there are limitations to this particular service. For instance, if I was to send this information to somebody else and I want to ensure that this data is kept encrypted, in that case, this particular or symmetric encryption doesn't necessarily work or fulfill my need, because I'll have to send somebody the encrypted file along with the shared key that I have in this case. Now remember, with symmetric encryption, you're using the same key to encrypt and decrypt the message. So if I am going to share that key with someone, and this sharing mechanism, if it is over the network or in any other method, unless I am going to physically see them and share this key, can be quite tricky. And if you can't ensure that this key is not being compromised, you can't ensure the actual data isn't compromised. So for that reason, we'll talk about the second method of encryption, which is asymmetric encryption. With asymmetric encryption, you are using two different keys or a pair of keys. One of them called a private key, which you keep private to yourself. Second, you have a public key that you can make available to public. So if you are sharing this information to anyone over the internet, you can make your public key available on your website or by other means where people can get hold of your public key. Now, if for instance I'm using my private key and I am encrypting a particular file that I want to share out with people, I can make this file available, let's say on my website, or I can send it to someone over the email. And for them to be able to see this file, they'll need to download a public key that I've made available for people to utilize. With the public key, they can open and read this file. Now you might be thinking, what's the point of creating a public key when anyone can download this key and read my file? Now remember the triad CIA that I spoke about earlier. We want to talk about the integrity of this file. In this mechanism, I can see that this file, or I can be ensured that this file can only come from that particular person that's encrypted this file using their own private key. Otherwise, using the pair or second pair, in this case the public key, it would not decrypt that message. If in transit anybody had altered or amended this file or done something to it, my public key would not open a file that I encrypted with my private key. So they can be ensured that they're receiving a file that was originally created by me and they're working with this particular document. Now, if somebody else wants to send me a file, they can use my public key and encrypt a document and send it back to me. Now, using my public key, they can only encrypt this data. They can't decrypt the information that they've created or encrypted using my public key. I'll have to use my private key to then decrypt this information. Now, this ensures that this data cannot be picked up by anybody else, and also the confirmation that this can only be used or can only be decrypted if somebody had used my public key. So I can ensure that this data wasn't taken by anybody or corrupted or amended in transit when it was sent to me. Now, both these mechanisms have their own users, and like I said, with symmetric, you could use it with banking and other apps, whereas asymmetric encryption, you can use this as digital signatures and also can be implemented with certificates and your HTTPS type of traffic, which is secured using transport layer security, and they use these methods of encrypting using asymmetric keys. Let's talk about hashing. Now, hashing might sound very similar to encryption, but obviously comes with slight differences. Now, with hashing, we are going to look at a plain text again. Now, what we are trying to do with plain text is we are converting it into a non-readable format. Again, sure, it sounds very similar to encryption, but we'll talk about how it's not encryption at all. Now, with hashing, we'll use an algorithm, in this case known as the hashing algorithm, which is typically a fixed sized key that we are going to use. Typically, these can be anywhere between 128 bits or 256 bits, and they keep on getting stronger. For example, 512 bits, and these are strong encryption keys or algorithms that you can use because they're utilizing that many number of bits to increase the security. So you'll use a fixed key value on as your hashing algorithm. Now, this hashing algorithm is going to be used to convert your original text into a non-readable format. So users that are going to pick up this file that was hashed, they cannot understand any information. Now, one of the key differences between this and encryption is that you cannot convert this file back into a readable format. Hashing is not designed to convert it back into the original readable format. Just like encryption, you do encryption and decryption. We don't do that with hashing. Now, the whole concept of hashing is that you should be able to use a hash value and check it against pre-stored hash values to ensure the two values matched, and you know then the original message that was used to encrypt this data would have been the same. Because you're using a fixed number of bits to encrypt, the output of your file would always be in a fixed value type. No matter your input is a word, a sentence, or whole document, the encryption or the hashing of this particular document or the hashed product would be always a fixed value. Now, this can be used or has been used for services that allow to verify passwords. So you can take the hash values and store them on your servers. Every time somebody authenticates, you can convert their password into hash and then verify the hash values with the two different values that you have, and it can confirm if somebody has typed in the correct password. Kind of prevents from revealing your password out to the public or over the networks or internet. However, this doesn't stop malicious actors to try and exploit this particular method of getting into services. Attacks like brute force attack and dictionary attacks can be used to guess random passwords at speed. These malicious actors can come up with a mechanism that can use random inputs as plain text and convert them into hash values, and these hash values that they are going to use then can be matched to the hash value that you have generated or sent to authenticate. If they get to match these values, they can reverse engineer to understand what was the initial input that was used to create that hash value that matches the hash value that you just used. Now, to stop from this happening, what we can do is introduce something known as salted hashing, which means we don't just use a fixed algorithm to hash a value. In fact, we can also add something else as another fixed value to this particular hash algorithm to make it more difficult for these malicious actors to work their way backwards. Typically, you can see timestamp values and other similar values added to these just to ensure that if somebody was to try this at a different time period, these values wouldn't match. And these are added to the hash value, and in return you will have a hash value that's got a combination of your word and a stamp or something else that can then be looked at as a final product. Reverse engineering that might be much more difficult for malicious actors to work out and can take them much longer to break your hashed value. All right, let's talk about compliance and compliance concepts. Government agencies and industry groups have created loads of different regulations, and they have used this to protect and govern your users' data. Now, for these reasons, different parts of the world, you need to ensure that you're complying with loads of different legislations and rules that are or laws that are out there. For that reason, we need to ensure a few things, like data residency. Where does your data physically reside? And if it's been used as part of a process, then where is it being processed? And how is it going to be utilized with other users? And is it going to be staying in the same physical location? Or does that process involve it to move the data across different regions? Now, there might be different implications on how the data should be stored and where it can be stored. And this is where we talk about data sovereignty. We want to make sure that your personal data that is collected by these organizations, these services, applications, they can abide by the laws and legislations depending on where you are in different parts of the world, to then make sure they can handle them and be compliant to some of these legislations. Finally, we want to talk about data privacy, and users should be notified of what data is being collected by these services. It can be your applications, can be different websites, different services where you log in and access these services. You want to ensure that you are made aware of the amount of data that this service is going to collect, what it will retain, how will it use that data to process information, and what will happen to your information, and how they will discard this particular details that they're collecting. And this all goes back down to abiding by the guidelines and principles of different legislations and laws that are implemented in different regions. Let's start with lesson number 2. In this lesson, we'll talk about concepts of identity and start talking about some of the terminologies like authentication and authorization, and look at identity as a security perimeter, discussing what identity services or identity related services are. Let's make a start to one of the first concepts: authentication and authorization. Surely the two terms that are very simple to understand and commonly used a lot of different times. Typically, when you talk about authentication and authorization, people generally know what you're talking about, but it's important to make sure you can differentiate between the two. Authentication, also known as auth-n, standing from authentication, is simply a process of somebody authenticating on who they say they are. So if you are trying to log into a service, that service should be able to identify who you are before they can let you in. Once you authenticate yourself, you might be granted access. Now, this is where the second part starts, which is authorization. Authorization, also sometimes referred as auth-z, simply allows you a level of access that should be permitted once you have authenticated yourself. For instance, I try to log into a database. I would be challenged by authentication to ensure I am allowed to log into that database with my username and password to ensure I am the correct person that's trying to log in. Once I log in, I might be then authorized to only look at parts of that database and maybe just be able to read the information that's on that database and not amend anything at all. So that's where the limitation of my authorization belong. Now, we can look at authentication and authorization in more detail, looking at some other aspects of identity. Typically, identity has always been referred as something that's limited within the boundaries of your on-premises environment and used as an aspect to identify a user. Now that has changed with modern advancements. We can now use identity as a perimeter security simply because our services are no longer confined to your on-premises environment. With users bringing their own devices and you connecting to services that are kept in the cloud across the globe, it is making it difficult for on-premises security to use just the conventional ways of working with things. Hence, we use identity as a security measure to understand the perimeter of your solution. Now, with identity, we are no longer limited to just user or as an individual that can be limited to this as identity. You can use applications, assign them identities. This can be to devices and any other services or devices that you can be using, such as IoT that might be implemented in your environment. Now, to manage some of these, we fall back onto the 4 pillars of your identity infrastructure. We discussed authentication and authorization on the previous slide, which simply ensures that you know who someone is when they're trying to log in, and in this case, a service or a user or an application that's trying to authenticate itself of who they are so they can be allowed access. Authorization would be what level of access are they granted or allowed when they carry on working and utilizing that service. Now, apart from these two, we do have 2 more areas that we need to understand. One of them is auditing. Any network administrator would like to audit the identity or audit services that are within your environment. That goes without saying for identity as well. You want to ensure you can understand all sorts of different types of data around identity. Who's logged in? When did they log in? Why did they log in? What did they change? And all sorts of different data that might be around that around the identity. So it's important that you can or you are able to audit as and when required to understand or secure your environment. Now, along with this, we do want to talk about one important aspect that is called administration. You want to ensure that you can administer your identity. For example, who has created them? Why was it created? Why is it updated? And all the changes that can be brought to any identity of a service or a user. For instance, they were deleted, they were amended to control other things, given additional rights. So you want to be able to administer an identity in your environment. Let's have a look at modern authentication. Now, before we do this, let's talk about conventional ways of authentication. Typically, when you are looking at authenticating services, you would have a particular user that will try to connect to, let's assume, a web server. This connection would typically happen with the user submitting details like username and password, and the server then in return authenticating the user. Now, if this user does not exist within that web server's details, this user would be rejected or be asked to create some credentials, basically going through creating a new form and completing a registration form. Now, there are some issues with this. If I have multiple web servers and multiple services that I need to work with, I need to create multiple identities to be able to log into these services, and for a single user to be able to memorize all these passwords can sometimes be tricky. I'm sure there are some people who are good at it, but not all of us can do this with ease. Now, for that reason, we want to introduce a concept of modern identity provider. What does this modern identity provider do for us? Now, modern identity providers, let's call them as IDP, the identity provider. what typically will happen is this identity provider will sit within a domain or an area where your users exist. So typically your user will have some sort of a trust built with this identity provider by either adding the device into the network or adding providing username and passwords as a conventional method, or there can be many other methods that they can authenticate themselves to this identity provider. In return, the identity provider simply builds a trust or knows who this user is. Once this trust is built, if this user tries to log into my web server again, what will typically happen is this user data is now sent back from this web server to understand who that user is and be able to identify how they can connect to this to web server. It will simply bounce back the signal to the user and ask this user to verify itself from its identity provider. Now, typically you'll see that this identity provider needs to have some sort of a trust relation built with this web server. So this web server is already connected or somehow has a relationship with your identity provider, so it can trust the details that it will provide. What will normally happen, this identity provider already knows the user, so it already trusts. So when this web server is asking this identity provider to authenticate this user, this identity provider will simply respond back with a token value back to the web server. Let's call this as T1. This token would typically have information that it trusts the user. The web server can either rely on the trust that is got with the identity provider, or it can use the private or the public IP address that we spoke about before, public keys. We mentioned encryption earlier on, so it can take the identity provider's public key and verify this token to see if it works. To authenticate, this is the integrity of this token is and is genuine. Based on this, this server now can simply allow this user to connect onto this web server and access services. In return, it can simply drop in a small cookie, or we call it C1, so it understands that there has been the whole authentication process and the access has been provided. So any future communication, it does not need to do the whole process again. Now in this case, the user is not providing his identity to that web server directly. That's kept internal, so that user doesn't have to provide those details again and again. And the user only authenticated itself once to the identity provider. Now, apart from this, if we consider looking at this user trying to now connect to, let's assume, a SharePoint site or any other application, or let's say another web service, let's assume a SharePoint site. Now the same process repeats itself. Typically, this user will request to log in, and this SharePoint site will simply respond back to connect to the identity provider to get the information about this user, and the identity provider will respond back with a token to allow to connect. Let's call this as T2, and simply in return, the user should then be able to communicate with this service as well. And again, this would probably drop in another cookie called C2 in this case. Now within this whole process, you can see that the user does not have to provide its sign-in details at multiple times to different services. And this is a beauty of using modern identity provider, because they provide you single sign-on services. So you don't have to sign in again and again for different services that you're using and working. Now, if you return back to the slides, you can see that we spoke about how this can be an ideal place, or as a modern identity provider can be an ideal place for auditing to be implemented, simply because if it becomes the center point where everything is going to be connecting and being authorized, why not audit this area so you can understand what user tried to connect to what service required authentication, and what users were given access to different services when they were working in an environment. So an ideal place to authenticate and to audit the details on their service environment. Now, Microsoft Azure Active Directory is a very good example of a cloud identity provider service that we have. In context of computer networks, a directory is a hierarchical structure that stores information about objects in the network. This can be your network users, your applications, your services, and Microsoft has been using Active Directory since Windows 2000. And one of the best known service is called Active Directory Domain Services, typically running on a service on a premises environment. And the server that is running this would typically be your domain controller. Now, with things evolving and using cloud services, we need a service that's evolving with environments and not just limited on premises. Hence, we'll look at services like Azure Active Directory that can be provided to you as identity as a service that can work on premises and across in cloud to provide you identity and access management. Now let's talk about concepts of federation services. Now, what happens if you are trying to access services that are not just limited to your environment and you want to access these services from other environments? Let's take a very quick example. I have domain A. Imagine this as one environment, and I have an identity provider for domain A, which can authenticate any service that's running within this identity provider. Now, we have a website running within domain A. Now, this website has a trust relationship built with identity provider, so it knows anything that's within its environment. We also have a domain B. This is a separate environment which has its own identity provider that can authenticate all the services within that domain. We have a user that sits within domain B that has a trust built with identity provider B, or has authenticated itself to identity provider B. Now, if this user tries to connect to this website, which is in a complete different environment or complete different domain, what typically will happen is this user's access or this user access request is simply forwarded back by the website to the identity provider that the website trusts, in this case, identity provider A. Now, identity provider A might not have any details about that particular user, and it won't be able to authenticate that user directly. What it can do is look at information like the user details that you provide to authenticate. In this case, let's assume we have John at contoso.net. The identity provider A can look at details like contoso.net and see if it understands or can find that service. Now, in this particular example, we have a trust relationship built between identity provider A and identity provider B. And again, it's important to understand that this trust relationship doesn't have to be bidirectional. In this case, is in one direction. Now, let's assume that identity provider B is contoso.net. My identity provider A will know that it understands where identity provider B exists. So what it will do is forward this information back and bounce it through the user to identity provider B to ensure that it can authenticate that user. Now, because user already has a relationship built with the identity provider B, it will simply generate a token to say, yes, I know this user, let this user in, let's call this T1, token generated by the identity provider B. And in this case, once again, it can verify this token between the two identity providers. Once it's happy with that, it will simply allow or send a token back to the website saying, yes, we can allow this user in. In this case, the identity provider A will send a token. Let's call this token T2 to connect to the web service, and it will allow it to access the service. Now, this is a simple environment where you can have services that can go beyond your environment and connect to other services using a concept called federation. So in this session, we discussed security and compliance concepts, talking about shared responsibility models, defense in depth, and CIA triad as cybersecurity strategies, zero trust, encryption, hashing, and then we looked at identity concepts, discussing difference between authentication and authorization, and described identity-related services. This concludes Module 1. We will take a quick 10 minutes break and start back with Module 2, Capabilities of Microsoft Identity and Access Management Solution.